All right, so get this, everyone. Today we're going deep on something a little bit freaky, a little bit fascinating. Can language models really reason, like actually reason like we do? We're talking about that ability to see patterns and solve puzzles even when the rules are totally unclear.
It's a huge hurdle in AI.
Yeah.
We haven't really been able to replicate that abstract reasoning in machines, like, at all.
Yeah, it's like the ultimate intelligence test, right? So to
Yeah.
really push AI to its limits, researchers created this crazy benchmark
Oh, yeah.
called the Abstraction and Reasoning Corpus, ARC.
The ARC.
The ARC.
Yep.
So picture this. A set of visual puzzles. They're like 2D grids with shapes and patterns, kind of like, I don't know, a really intense game of Tetris or something.
Yeah.
And you get a few examples of how one grid changes into another.
And the challenge is, can you crack the code? Can you figure out what that rule is that governs the transformation?
Yeah,
And then apply it to a new grid to predict what the output's going to be.
right.
These puzzles can be really tough for humans, too.
Oh, absolutely. And up until now, they've been a major roadblock for language models.
Mhm.
You know, those AI systems that are trained on just mountains and mountains of text data,
Right.
they can predict the next word in a sentence, sometimes even write whole stories. But this kind of abstract reasoning,
It's been a challenge.
yeah, not so much.
Yeah, they struggle with, like you said, those logical leaps,
Yeah.
thinking outside the box like ARC requires.
But that might be changing because of some really interesting research from MIT. They're using a technique called test time training, TTT.
TTT.
And they're getting some pretty amazing results. So you've given us a ton of research on this. So let's dive in. What makes this TTT approach so different, and what could it mean for AI in the future?
The key is that TTT allows the models to learn during the problem-solving process,
Yeah.
not just before.
So instead of just like, cramming for a test and hoping that it remembers all the right answers,
Right.
we're giving them the ability to learn in real time as they're trying to solve the problem.
Exactly, yeah.
Yeah.
Which makes them so much more adaptable.
Wow. That's wild.
Yeah. More flexible than traditional language models.
So, how does this TTT magic work? Like, what's the secret sauce? What are the key ingredients to making it work so well?
Okay, so the MIT researchers, they found there are three main things that make TTT effective on these ARC tasks. First, you got to start with a language model that's already been trained on tasks that have, kind of a similar flavor to ARC, things like visual reasoning or pattern recognition. So they used this large language model, one from the Llama family, and they fine-tuned it using a mix of existing and synthetic tasks.
Okay, so it's like giving the model a solid foundation in the basics before you throw it into the deep end of abstract reasoning. Got it. What about the second ingredient?
The second key is how you create the training data during the test time, when the model's actually trying to figure out the problem.
Oh, so it's not about those massive data sets they use in pre-training, but creating like a specific cheat sheet on the fly.
Right. And they use a really clever two-step process. First, they take those few examples of transformations that you do have, and they create a bunch of new mini problems. Each example takes a turn being the test case, and the others act like a tiny training set.
Interesting. So they're really making the model think through the problem, not just memorize answers.
Right. And the second step in this whole data creation process is they augment these mini problems with transformations. So you take those grid puzzles and imagine rotating them, flipping them, even swapping colors around.
Ah, so it's like you're introducing controlled chaos, but in a way that forces the model to be more flexible and robust in its reasoning.
Exactly, yeah. It's like, teaching a kid to recognize a square. It doesn't matter which way you turn it. And the third ingredient that makes TTT really powerful is using something called task-specific adapters.
Adapters, what are those?
Think of them like specialized modules. You can plug them into the main language model. Instead of trying to train one huge model that's good at everything, you have these smaller experts.
Oh, okay.
Each one's fine-tuned to handle a specific task.
Got it.
It's about efficiency, getting the most out of those computing resources during test time.
So instead of a jack of all trades, we have a team of specialists.
Right.
That's really interesting. Now, we've talked about the training, but what about actually using the trained model to make predictions?
That's where their strategy called augmented inference comes in. And it uses those transformations we talked about.
Now that you mention it, I am really curious about those transformations, how they fit into the big picture. Can you break that down a little more?
Sure. So you take the input grid, you apply a bunch of these transformations to it, rotations, flips, all that. Then you get predictions for each transformed version.
So it's like asking the model, okay, what happens if we flip this thing upside down? What if we rotate it 90 degrees?
Exactly. So you're getting multiple perspectives on the same problem. And since those transformations are invertible, you can always undo them and get those predictions back in the original configuration.
Ah, okay, so you're combining predictions from all these different, I guess you could say, warped versions,
Yeah,
and that gives you a more accurate picture of the solution.
exactly. They use a really clever voting scheme to combine these predictions,
Okay.
which helps reduce errors and really pinpoint the best solution.
This is starting to sound like a really complex system. I'm kind of blown away by how creative they had to be with this, but does it actually work? Like, does TTT actually make them better at ARC tasks?
Oh, it absolutely does.
Yeah.
That's where things get really exciting.
Yeah.
They found that this TTT approach, it significantly boosted their accuracy on ARC.
Hmm.
It beat previous approaches that were just neural and even got close to the average human score on the benchmark.
Wait, so you're saying they got a language model to solve these abstract reasoning puzzles almost as well as a person?
Yeah.
That's huge.
But there are a couple of things to keep in mind. This approach can be computationally expensive, it takes a while to run, and there's potential for something called data leakage. That means the model might have accidentally seen some of the ARC puzzles during its initial training.
Okay, so there are limitations, like with any new research. But even with that, this really challenges what we thought language models could do.
For sure, this research suggests that maybe we've been underestimating their reasoning abilities all along.
Ooh, that's interesting. And I'm ready to go deeper. Let's get into the details of how they actually implemented this TTT approach, because, the devil's always in the details.
For sure. One of the things that really stood out to me was how they generated those training examples on the fly during test time. Remember that two-step process?
Yeah.
It's much more intricate than it might seem.
All right, let's hear it.
So with these leave one out tasks, it's not just, oh, pick one example and that's the test. They actually create different versions, each with a different example taken out.
So instead of just practicing on a couple examples, they're making the model look at every possible angle, every relationship between the input and the output.
Exactly. They're really making it think deeply about the problem.
Yeah?
Consider all the nuances, all the possibilities.
Okay, that makes sense. Now, what about those transformations? Like, how do they choose which ones to use? How do they actually work?
That's where it gets really smart. They use a mix of these basic geometric transformations like rotations, flips, reflections, as well as some more complex ones that change the colors and patterns in the grids.
Wow, so they're really putting those grids through the ringer,
Yeah,
twisting and turning them every which way.
totally.
But I'm guessing there's a reason for all this warping.
There is. The key is that all these transformations are invertible. You can always undo them to get back to the original grid.
Okay.
So that means the model is still learning to solve the original problem, even though it's practicing on all these messed up versions.
So even though they look different, the logic behind the puzzle stays the same. It's like looking at the same object from different angles. It might look different, but it's still the same thing.
That's a perfect way to put it.
Whoa.
And, this approach actually has some really, really interesting implications. It's bigger than just solving these puzzles.
Okay, now I'm intrigued. Implications, huh? If this test time training can make language models this good at reasoning, what does that mean for us in the real world? What kind of problems can we start to tackle?
Ooh, the possibilities are huge. Really exciting. Think about scientific discovery.
Okay.
Imagine AI that can analyze massive data sets, find patterns we might miss, and even come up with new hypotheses to test.
Wow.
It could revolutionize fields like medicine, material science, climate modeling, anything really.
So instead of just crunching numbers, AI could become a partner in research,
Exactly.
helping us understand the world in new ways.
Right. And it's not just science. What about education? Think about AI tutors that adapt to how each student learns.
Oh, interesting.
Help them understand those tough concepts better.
Yeah, that would be a game changer for education.
Yeah.
What about creative stuff like music or art? Could this AI help artists come up with new ideas, push their creativity further?
Totally. It's not about replacing human creativity, but enhancing it, giving them new tools to work with.
I like that. And this kind of reasoning ability could also change things like engineering and design, too.
Oh, absolutely.
Imagine AI helping us design better cities, safer transportation, even whole new technologies we haven't thought of yet.
The big takeaway here is that test time training isn't just about solving puzzles. It's about giving AI the ability to think more like we do, flexibly, creatively, and really being able to adapt.
And that, like you said, could change pretty much everything.
It could.
But with any powerful new technology, there are some downsides to think about.
Oh, definitely. We have to develop these technologies responsibly, carefully,
Yeah,
thinking about the ethical implications, the potential risks, along with all the good stuff.
totally agree. Now, I know you said this research is still pretty new,
It is, yeah.
but it's making waves in the AI world. What are some of the big questions or challenges that researchers are trying to figure out as they build on this work?
One of the biggest hurdles is scaling it up. Right now, test time training takes a lot of computing power, especially for harder tasks. So researchers are trying to make it more efficient, so it can be used for a wider range of problems.
Right, efficiency is always key with AI. What about that data leakage problem you mentioned? Are there any solutions for that?
People are definitely working on ways to minimize that, like really carefully checking those training data sets to make sure they don't have any of the test data in them, and coming up with new training methods that are less likely to leak.
So it sounds like there's still work to be done,
Definitely, yeah.
but it's good to know that researchers are on top of these challenges. Now, we've talked a lot about the technical stuff, the potential impact, but I'm curious what really stood out to you about this research? What made you go, whoa, this is really cool?
What fascinates me is how TTT could bridge that gap between human intelligence and artificial intelligence.
Mm-hmm.
For a long time, we've seen them as separate,
Yeah.
even opposites. But TTT shows us maybe the lines are blurrier than we thought.
Yeah, it's like we're starting to see hints of human-like thought in these systems.
Right.
And that's exciting, but also a little bit unnerving.
It is, yeah. It makes you question what intelligence even is.
Yeah.
If we can make machines that learn and reason like us, what does that say about our abilities?
Those are big questions, and I don't think we have all the answers yet. But it's really cool to be a part of this, to see these breakthroughs happening. And I have to say, I'm really impressed by how elegant and clever that transformations technique is.
Oh, for sure.
It's a simple idea, but so powerful.
It really is, and it shows how creative these researchers are. They're not just feeding data into algorithms. They're thinking hard about how to represent knowledge in a way machines can understand.
It's like they're teaching AI to see the world the way we do, to understand all those little things we usually don't even think about. Now, before we wrap up this awesome conversation, what are your thoughts on the long-term effects of all this? What could it mean for the future of AI, and how might it change our world in the years to come?
I think it's safe to say we're still early on in understanding what test time training can really do,
Yeah.
but based on this research, the future of AI is going to be so much more dynamic,
Hmm.
adaptable, and yeah, maybe even intelligent than we ever imagined.
And that intelligence will probably be different from ours, with its own strengths and weaknesses.
Of course, yeah. It's not about making copies of humans, it's about broadening the idea of intelligence itself, finding new ways of thinking and solving problems.
That's a great way to put it. It's like we're opening up a whole new kind of intelligence, one that could help us solve some of the biggest problems we face and unlock new creativity and innovation.
Yeah.
Now, I'm sure our listeners are probably itching to learn more about this. So let's talk about some resources they can check out.
Sounds good.
Where should they start?
Well, if you're ready to dive into the nitty-gritty, the original research paper by the MIT team is the way to go.
Okay.
It's called The Surprising Effectiveness of Test Time Training for Abstract Reasoning.
Kitschy.
I know, right? It might sound scary, but they do a good job of explaining things clearly, even if you're not a computer science whiz.
And the cool thing about these academic papers is they often lead you to other research through their citations, so you can go down the rabbit hole and see what other people are working on.
Exactly. Yeah.
It's like a choose your own adventure for your brain.
I like that.
Now, if you want to get hands-on and see those ARC puzzles yourself, check out the Abstraction and Reasoning Corpus website. They have the whole data set there.
Take the light.
And some tools to help you visualize and play around with those grids. You can even try to solve some and see if you can beat the AI.
That'd be fun.
For those who want a more casual introduction, there are some really great blog posts and articles that explain test time training in simpler terms.
Yeah, for sure.
We'll include links to our favorites in the show notes.
Definitely.
Okay, so you've got the research paper, the ARC dataset, and some introductory articles. What's the next step on this learning journey?
This is the fun part. Start digging into other research related to test time training.
Okay.
See what other problems people are trying to solve with it, what breakthroughs are happening, what new challenges are popping up. Just follow your curiosity, you know? You never know what amazing things you might find.
And as you explore, it's important to think critically. What are the limitations of this approach?
Yeah.
What are the potential benefits and risks? Are there any ethical concerns?
All good questions.
Okay.
As AI gets more powerful and becomes a bigger part of our lives, it's crucial that we all understand it and help shape its future in a good way.
Very well said. We hope this deep dive has piqued your interest and motivated you to learn more about the crazy world of AI. Who knows what amazing discoveries are waiting to be made?
It really is an exciting time to be a part of this. I can't wait to see what happens next.
So, until next time, keep those brains buzzing and stay curious.
Yeah, it really makes you think, doesn't it? There's so much we're still figuring out when it comes to AI.
It really does. It's like we've just opened the door to a whole new level of understanding about intelligence, you know? And who knows what we'll find next.
Exactly. It's exciting, but it also shows us how important it is for everyone to be a part of the conversation about AI, not just the tech people.
Absolutely. We all need to be involved in shaping how AI develops. So let's give our listeners the tools they need to learn more about test time training and all this abstract reasoning stuff. Where should they start?
Well, if you're ready to dive deep into the research, I definitely recommend checking out that paper from MIT we mentioned earlier. It's called The Surprising Effectiveness of Test Time Training for Abstract Reasoning. I know the title's a mouthful, but honestly, they did a great job explaining everything. You don't need a computer science degree to understand it.
Plus, those academic papers are great because they usually cite a bunch of other related
Hmm.
research. So you can follow those links and really go down the rabbit hole, see what other researchers are working
Oh,
on.
yeah, it's like a choose your own adventure for your brain.
Exactly. Now, if you want to actually play around with those ARC puzzles we've been talking about, you should head over to the Abstraction and Reasoning Corpus website. They've got the whole data set there, plus some cool tools to help you visualize and interact with the grids. You can even try solving some yourself and see if you're smarter than the AI.
It's a fun challenge.
Now, for folks who prefer something a little easier to digest, there are some great blog posts and articles out there that break down the basics of test time training in simpler terms.
Yeah, for sure. We'll make sure to include links to some of our favorites in the show notes.
Awesome. Okay, so we've got the research paper, the ARC dataset, and some introductory articles. What's next? Where should our listeners go from here?
Here's where it gets really interesting. Start branching out and exploring other research related to test time training. See what other problems researchers are using it for, what new discoveries are they making, what challenges are they running into. Just follow your curiosity and see where it takes you. You never know what you might find.
And as you're exploring, it's important to think critically about what you're learning. Ask yourself, what are the limitations of this approach? What are the potential benefits and risks? Are there any ethical concerns?
Exactly. The more we understand about AI, the better equipped we'll be to guide its development in a way that benefits everyone.
Couldn't have said it better myself. We hope this deep dive has inspired you to keep learning and exploring the incredible world of AI. There's so much more to discover, and who knows what amazing breakthroughs are just around the corner. It's a really exciting time to be following this field. I can't wait to see what the future holds.
Well, that's all the time we have for today. Thanks for joining us on this journey into the fascinating world of abstract reasoning and test time training. We'll catch you next time.